All of participants are expected to mute the audio and only unmute the video during the event. We cordially invite you to take your own firm and comfort seat in your own room, and please avoid the backlight. Make sure that you have a good and stable internet connection. If you have an earphone or headset, we recommend you to use it so that your voice can clearly and loudly to be heard. During the Q&A discussion session, all participants, please use the chat box to deliver the questions. Thank you for your cooperation and consideration.
Okay, it's already 9 o'clock right now, so we will start our agenda. And the Honorable of the Director of Hazardous and Non-Hazardous Waste Management of the Ministry of Environment and Forestry of Republik Indonesia, Bapak Insinyur Ahmad Gunawan Wicaksono MAS IPU, that he will be later join with us. And the Honorable of Professor G. Liu, the Director of Science and Technology Innovative Center for Circular Economy and Green Innovative Resources, and the Vice President of the National Taiwan University of Science and Technology. Good morning, Professor. And Honorable Vice Rector of Research, Innovation, Cooperation, and Alumni of Institut Teknologi 10 November, Bapak Dr. Bambang Pramujati, ST, MSc, Eng. Selamat pagi, Pak Bambang. And Honorable Distinguished Professor Ching Huali from Taiyei University, Taiwan, Distinguished Professor Yulina Trihadiningrum from Institut Teknologi 10 November, and Dr. Jenny Lee from Widya Mandala Catholic University as a speaker in this webinar. Good morning for all of distinguished professor and honorable speaker, and also Honorable Dr. Tovani as a Director of Research Center and Community Services of Institut Teknologi 10 November, and also Ibu Professor Felicia as a Vice Director of STIC Sekir, and all participants in the e-waste webinar today. Assalamualaikum warahmatullahi wabarakatuh, and good morning. Let us pray to present of Almighty God, because with the grace and guidance of her, we can present in this webinar. And the themes of the webinar today is the e-waste management, and the webinar was conducted also to commemorate of Earth Day on the 22nd of April with the themes of Invest to Our Planet. The webinar conducted under Science and Technology Innovative Center for Circular Economy and Green Innovation Resources. And this research center is a collaboration between the National Taiwan University of Science and Technology with the Research Center of Infrastructure and Sustainable Environment of Directorate of Research and Community Services of Institut Teknologi 10 November with Widya Mandala Catholic University. And on this event, our agenda is the first one is opening, and the second one is speech from Professor G.C. Liu as the Director of Science and Technology Innovative Center for Circular Economy and Green Innovative Resources. And the third one is welcoming speech from Vice Rector Dr. Bambang Pramujati, and also officially open this webinar. And continue by our main agenda, the explanation of each topic from each distinguished professor and honorable speaker. And without overdue, I would like to invite Professor G.C. Liu to deliver the speech about the research center and the themes of webinar today. So the time is yours, Professor Liu.
Thank you very much, Ibu Wawa. Selamat pagi. Good morning.
Selamat pagi.
Ramadan Mubarak. Blessed Ramadan. On behalf of STIC, Taiwan Tech, I'd like to welcome everyone to this webinar. And especially we are honored to have Vice President Professor Bambang to be with us. And also Dean Suryadi, Vice Dean Felicia from William Mandela Catholic University. It's very meaningful that we have the webinar today on the management of e-waste, because this is a Friday during the Holy Ramadan, and this is also the Earth Day. Okay. We are very pleased to have heavyweight lecturers, Professor Ibu Yulina, my old friend, Dean Li Qinhua, a renowned scholar on e-waste management who owns many patents that are successfully commercialized. And we are also very happy to have the young, energetic, aspiring lecturers, Professor Jenny Lee from William Mandela, to introduce on the proper management of e-waste. I'd like to wish this webinar a very aspiring and fruitful, successful one. Thank you very much. Thank you.
Thank you very much, Professor Liu. And we hope that with this collaboration, we will make a small step and big impact to our Earth. And the second speech, I would like to invite Vice Rector of Research, Innovative Cooperation and Alumni of Institut Teknologi 10 November, Bapak Dr. Bambang Pramujati, to deliver the welcome speech and officially also open this webinar. Without overdue, please, Pak Bambang.
Thank you, Bu Wawa. Bisa dengar suara saya?
Ya, bisa didengar, Pak. Dengan
Thank you
jelas.
very much. Assalamualaikum warahmatullahi wabarakatuh. Good
Waalaikumsalam
morning, everyone. The Honorable the Director of Hazardous and Non-Hazardous Waste Management of the Ministry of Environment and Forestry of Republik Indonesia, Bapak Ahmad Gunawan Wicaksono, the Honorable Professor G.C. Liu, as the Director of Science and Technology Innovative Center for Circular Economy and Green Innovative Resources, STIC Chair, and the Vice President of the NTUSD Taiwan. Good morning, Prof. Liu. How are you? It's a long time no see. Distinguished speakers, Prof. Qinghua Li from Daji University, and then distinguished speaker as well, Professor Yulina Trihadiningrum from ITS, and Dr. Jenny Lee from Vidya Mandala Catholic University. Thank you for your coming, and also your willingness to transfer your knowledge to every one of us. And honorable guest, Dr. Fani, as the Director of Research and Community Services of ITS, Prof. Felicia and Dr. Varma Dewanti as a Vice Director of STIC here, as well as all participants in this e-waste webinar today. Good morning, everyone. Praise to God and Almighty for the health and opportunity that are given to us, such that we are able to gather here in this virtual event. You know, today, the April 22nd is the Earth Day celebration. So the Earth Day 2022nd theme is the invest in our planet. So what can we do in this Earth Day 2022? A lot of we can do together. So we need to act boldly, we need to innovate broadly, and we need to implement equitably. One of the big problem with waste management, especially in developing country like us, Indonesia, we have a very big problem in this kind of waste management. Today, the webinar topic is related to e-waste management, and ITS is one of a big education institution in Indonesia, also produces a lot of e-waste that needs to be managed very well because it's categorized as a hazardous waste. Another obstacle in managing electronic waste is public participation and the knowledge of the potential hazard. Several cases of electronic waste import still occurs in Indonesia, and the location of the importer usually tends to be people with low levels of welfare and knowledge. Based on this problem, the Science and Technology Innovative Center for Circular Economy and Green Innovative Resources, or we can call it STIC Sejir, conducted the webinar related to this topic. So the STIC Sejir is a collaboration between National Taiwan University of Science and Technology and UST, Institut Teknologi 10 November ITS Surabaya, under the Research Center for Infrastructure and Sustainable Environment ITS, as well as Vidya Mandala Surabaya Catholic University. This consortium research was conducted until 2024, and one of the goals related to how to manage e-waste in a proper way and how the specific treatments process need to be conducted. Hopefully, this collaboration will last more than 2024, and we can do a lot more together. This webinar hopefully could come up with a good discussion and lesson learned from Taiwan about how they manage their e-waste, which might also can be adopted by Indonesian in the future. Thank you very much for all speakers this morning, Bapak Ahmad Gunawan Wicaksono, Prof. Ching Huali, Prof. Yulina, and Dr. Jenny Lee, who is willing to spending your busy time sharing with us valuable information that we could learn from you. Lastly, I hope that all participants could also gain more knowledge from this event, and hopefully we can all have a fruitful discussion. Thank you and have a successful webinar. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Pak Bambang Pramujati. And as mentioned by our Vice Rector, that hope that this collaboration could be successful to contribute in research and innovation in the future. Okay, before we start our agenda, we will continue to show to all of the participants the video of this research center. And the research center of STIC Sekir is under the collaboration of National Taiwan University of Science and Technology, ITS, and Vidya Mandala University. So please, Mbak Dewi.
The center is set up among Taiwan Tech, ITS, and Vidya Mandala Catholic University, Surabaya. The main goal of the center is to strengthen cooperation on science and technology between Indonesia and Taiwan, and we will focus on recycle and reuse of industrial waste. Targeted compounds include fly ash, burn slag, and spent bleaching oil that are of significant amount and to our common interest. It will also involve 1,400 strong alumni in Indonesia, and we will engage private sectors, NPOs, and research institutes.
Through this international collaboration, Institute Teknologi 10 November could strengthen the collaboration between National Taiwan University of Science and Technology, Widya Mandala Catholic University, and Indonesian Institute of Science. This research center was developed as a platform to connect the researchers from different universities from ITS, Widya Mandala, LIPI, and NTUST with the experts from industry that work together to have the research regarding to the eco-green solution and for the circular economy and sustainability. Waste utilization is one of the implementation of eco-green solution, and we know that Indonesia could be developed this model to recover of the waste and use as a many different purpose, and also we can develop a good impact to the environment and also to the society.
We are proud that ITS, Institut Teknologi 10 November, Surabaya, Indonesia, has been a part of this prestigious international collaboration. The topic of circular economy and green innovative resource matches with the ITS vision and the world focus. So I believe that the research center opens opportunities for researchers to expand the outcome, the connection, and also the international collaborations. In addition, it boosts the ITS contributions to the nation.
Besides a medium to the international research collaboration, this research center wants to provide a database experts from Indonesia and Taiwan so they can find a sparring partner to work together for international research collaboration. By this research center, we do hope that the spirit of doing research and innovation for Indonesian academia can grow and they can have a broader link for collaboration in international scale. And when a new researcher come up, they can use this platform to build collaboration for their research and also support their career. It is a great pleasure that scientists and engineers from Indonesia has a place to work together to build a collaboration with other countries, especially Taiwan. This is a proof that Indonesian researchers can work together and compete with others in the world-class research. Lembaga Ilmu Pengetahuan Indonesia, or we call LIPI, support the research center, and together we can solve industrial problems, especially for waste treatment and reuse. Through Taiwan Indonesia Research Center, we can build triple helix research by connecting government, university, and industry.
As a rector of Widya Mandala Surabaya Catholic University, it is my great honor to be part of Taiwan Indonesia Research Center to promote international collaboration in order to develop the innovative ideas from Indonesian academia for Indonesia circular economy.
Indonesia needs intensive construction as a modern and developed country. And we know that the source of waste, especially from industrial waste, is abundant in Indonesia. We can use this waste for utilization, and also this is a small step that we can use as an eco-green solution. For example, we have produced a lot of food slugs that can be used as a cement additive and also for construction. We also produce a lot of spent bleaching earth that can be used for cement making and also for the adsorbent.
We already structured STIC roadmap based on our goal, which is circular economy and green innovative resource. In the first year, we established a platform for the collaboration of industry, academia, government administrator. And it followed by a data bank of experts to support potential collaboration and capacity building in the second year. And in the third year, we focused on expanding this collaboration as well as capacity building through seminar, workshop, and exhibition. STIC Saiger also cooperate with Minister of Science and Technology Taiwan and Taipei Economic and Trade Office as Taiwan representative in Indonesia who fully support this center. The Science and Technology Innovation Center raised two main issues, namely circular economy and green innovative resource. The goal of this center to strengthen the cooperation on science and technology, in line with new southbound policy of Taiwan government.
Be better together. Together, be greener. Thank you.
So, thank you very much. And for all the participants, before we jump to main agenda, we might have photo session together. Please turn on your camera, and for the organizing committee, maybe we can take the photo first. Okay, so please you can turn on your camera. Okay, so we have 166 of participants today. Okay, already taken Mbak Dewi for the first?
Yes, Bu Warma.
Okay. Okay, we can take from the first slide. Smile. And the second, we have 7 here. Okay. Already?
Yes.
Okay. And the third? Okay, thank you. And the fourth slide. Please turn on the camera. And 5. 6. Okay, the last one. Yeah. Okay, thank you very much. Thank you, Pak Bambang Pramujati, Professor C.C. Liu, and all also. So we will go to the main agenda. And for the main agenda, I would like to invite Ibu Ainul Firdatunisa, STS MSc, as a moderator for this event and lead the discussion. So for Ibu Nisa, the time is yours.
Yeah, thank you, Bu Warma, for the introduction. Good morning, everyone. My name is Ainul Firdatunisa. I'll be the moderator for today's webinar. As previously mentioned by Ibu Warma, today we will have 2 sessions. The first session, we will listen to the presentation from our speakers. First is from Professor Dr. Yulina Trihadiningrum, from ITS. And then the second, we will listen to the presentation from Professor Qinghua Li from Daya University. Before we start to listen from the presentation from Professor Yulina, I will first read out the curriculum vitae from Professor Yulina. Professor Dr. Yulina Trihadiningrum, Master of Applied Science, is the Distinguished Professor of Environmental Engineering Department, Institut Teknologi 10 November. She holds bachelor degree from Institut Teknologi Bandung and also master degree from University of New South Wales, Australia. Also doctoral degree from University of Andhra. Her research field covers electronic waste, microplastic, solid and hazardous waste management. So for the first presentation, we will listen to the presentation from Professor Yulina. But before, just a little housekeeping before we get started. So for our participant, please ensure that you turn off your microphone during the presentation. And please, if you have any question, type the question in the chat box, and then we will cover them during the discussion session. So Professor Yulina, you have 25 minutes for the presentation. And then after that, we will continue with the second speaker, and then we will have a discussion session. Professor Yulina, the time is yours.
Okay, thank you very much, Ibu Ainur, Professor Liu, Dr. Wama, Professor Tingwali, Dr. Jenny Lee, participants, students, and ladies and gentlemen, a very good morning to all of you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Topic of my presentation is concerning e-waste management research in Indonesia. But before I start, I would like to mention that research activities in e-waste are actually more limited compared to research on the municipal solid waste management, hazardous waste, and wastewater treatment. So, including in our laboratory, the number of research on e-waste is still very limited. Anyway, because I was asked to give this presentation, so I will try to do my best. Next, please. Next, please. So I would start with this talk with the definition of e-waste. Actually, government regulation concerning e-waste, which is a term as specific waste in Indonesia, has just been established, has just been enacted in 2020. And Indonesia has classified e-waste as specific waste. And it is termed as electronic device which can no longer be used. And it is defined as electronic or electrical device operated with battery or electricity, which is unused and disposed of by the last owner. So that is the definition that I got in this regulation concerning specific waste. And one important thing for the e-waste is that after sorting and collection stages, all activities in the utilization, treatment, and or landfilling activities should follow regulation concerning hazardous waste management. So there are a number of regulations which are related to e-waste management. Next, please. And this is the data concerning the e-waste generation in Indonesia. With a very high population of 273 million, Indonesia generates 2 million metric tons of e-waste in 2029. And this has placed Indonesia as the 7th largest e-waste generator worldwide. And 56% of the e-waste is generated in Java, of which population is 145 million. Then, of course, the e-waste may give high pressure to the environment if it is not properly treated. So, for those from outside of Indonesia, this is Java Island next. Next. So, this is the situation of Indonesia as the largest, one of the largest e-waste generator in the world after China, USA, India, Japan, Brazil, and Russia. And indeed, Indonesia is the largest e-waste generator in Southeast Asia. Next, please. So this is, I think, because of the high population. The annual domestic demand of electronics devices in Indonesia is very high. For example, for TV, the market demand in 2019 was 3.5 million sets. Next. Oh, sorry. Back to the first. And the demand decreased a little bit during 2020 due to the pandemic situation, but back to normal during 2021. And cell phone, amazingly, the demand for cell phone in 2019 is 101 million sets, and it is decreasing a bit in 2020. Next, please. Well, these are some interesting data concerning the lifespan of home electronic appliances. So, for TV, for example, The active use of TV in average is 6.43 years, but the storage time of the TV waste is quite high. It is more than 2.23 years in average. Please, next please. So the same as, no, I did with animation. So the same as TV, the other kinds of e-waste is generally spent for quite a long time in the customer place. So generally it takes 1 year or even more, or up to 10 years and even more than 20 years in the government offices. Later we are going to see the data. And this makes the position span of the e-waste in the customer's place become longer. Next, please. So what is actually the reason why the e-waste is kept for a long time by the users? So most of the respondents, when they are having a survey in 2018, they said that the reason they are keeping the e-waste for a long time is they do not know the legal place to dispose of. So what happened to the other parts of e-waste which are disposed of? So part of the e-waste which are disposed of is gone to the scavenger and gone to the second-hand shops and others. Next, please. So I would like to highlight some problems. I cannot explain all of the problems, that there are four problems that I would like to share. The first problem is the e-waste collection facility in almost all cities in Indonesia is very lacking. And this makes the generators keep the e-waste for a long time at source. So the picture on the right side is the condition of the stored e-waste in an office in Surabaya city. So it's piled up to large amount. So there are also reasons, especially for the government institution, why they like to keep e-waste for a long time in their storage room. And the second problem is the lack of awareness among the generators concerning e-waste hazards and proper management. And this has caused mixed handling of the e-waste with other domestic solid waste. So the picture on the right side show that one waste picker collect e-waste from a landfill in Jakarta. And but fortunately, right, I was muted, sorry. So can you hear my voice now? Because
yes, Bu Yuli.
I was
yes,
muted just now.
Yeah, we can hear. Sorry for.
So
yeah.
The one waste picker collect e-waste from landfill in Jakarta, but fortunately Jakarta now has established good e-waste collection system, and we expect that other cities in Indonesia will follow this step of e-waste collection. Next, please. The other problem is material recovery and recycling still much depend on illegal recyclers. And consequently, the recycling rate and revenue are hard to estimate, and disposal of residual waste from recycling business is generally unknown, and the environmental and health impacts are still uncontrolled. And the picture in the right side is an illegal recycler whose business is located near Citarum River, and he was blamed to pollute the river, so the Ministry of Environment has closed his activity. The fourth problem is the removal procedure of e-waste with state property status should follow strict regulation for government asset management. This is a problem of government offices, including state universities and schools. So they have a quite complicated procedure to remove the e-waste from the offices. And this has caused the e-waste stored for a long time in the government offices. So the high quantity of stored state property e-waste needs a large space for storing in the centralized government collection point. So the picture on the right side show the lack of spaces for storing the e-waste in Surabaya city from the government offices. So they put it outdoor, and this may emit the hazardous components from the e-waste. I think Professor Lee will explain more elaborately about components of e-waste. Next, please. So, based on what I have talked about, there are potential of research opportunities. The first one is material flow analysis. So indeed, we need quantitative data on material flow during management of e-waste from source to the recycling and disposal facilities, which are now still very lacking. These data are indeed important to support e-waste recycling industries and to estimate the potential release of pollutants to the environment. Other research opportunities are consumer behavior, e-waste generation, e-waste management, economic analysis, legal aspect in e-waste management, health and environmental aspect. And the last but very importantly is research on the appropriate and clean recycling technology of e-waste. Because of the high generation of e-waste in Indonesia, so it is very potential to do recovery of precious metals and other precious, perhaps rare metals, which is included in the e-waste. And I think Dr. Jenny Lee will explain about this more elaborately. Next, please. So these are just a graph which mention distribution of scientific publication on e-waste based on countries. So the main contributor of scientific publication is China, followed by India, USA, but also Indonesia has contributed, how many is this? 12 publications in the last 7 years. And next, please. And topics of the various published, in the various published journals are here. We can see the green one. The green one is on the management aspect. This is published almost every year, but concern to the environment start in 2010, and publication on recovery technology, it is shown in the violet color. It is started from 2012 up to date. Next, please. So I would like to share my study, not my study, actually it was done by a group of people. So what we have studied, part of our study on e-waste is concerning e-waste generation and management condition in some institution, in local government offices, in university, and also in schools. So e-waste in government offices is still considered and treated as state property. This is, I think, an obstacle because this caused the e-waste tended to be kept for a long time in the office, in the storeroom of the office. And our observation was done during 2017. And at that time, the regulation concerning specific waste management and e-waste management has not been enacted. So we observed several municipal offices and also one centralized storage facility of the used government owned used materials in Surabaya city. Next, please. So this is just one example of data that we got from the Municipal Cleansing Agency of Surabaya city. So they kept more than 1 year of this e-waste in their storeroom, and the e-waste comprised of monitor, printer, air condition, and others. And well, the amount is up to more than 555, half a ton. The quantity is more than half a ton with storage time of more than 1 year. Next, please. So we also noted the stored e-waste in the other two government offices. Actually, there are more than 3 that we observed, but I only put some in here. So Public Work Agency for Highways and Drainage, also the Living Environment Agency of Surabaya City also have the e-waste in their storeroom. And with because of the lower number of staff members there, the generation is less than the municipal cleansing agency in number 1. And surprisingly, what is stored in the centralized storage of procurement in asset management service, the number of e-waste units there is more than 5,000 with a total weight of 30 tons. So this e-waste was collected from all government offices, including schools and university. Because after being stored here, the e-waste should have to be removed, and they are going to organize auction or lelang for the e-waste to the winning buyers. Next, please. So these are the situation, the piles of e-waste in indoor storage room, and many of the many pieces of the e-waste, including non-e-waste materials, are placed outdoor. And what happened is, next, due to the high exposure of sunlight and heavy rainfall, there might be exposure, they might be release of hazardous components to the environment. Next, please. So this figure mentioned about e-waste management stages in government institutions. So the broken electronics normally go for reparation first, but if it is unrepairable, then the large e-waste, the large size e-waste will go for inventory listing. Then after that, it will be stored in the storage room of the generator, and then there will be deletion states from the properties, the state property status from the government property status. And this is the rather complicated stage that the office should apply for approval to the city mayor for the deletion of these broken government asset materials from this government property status to not non-government status. And when the approval is received from the mayor, then the e-waste can be transported to the centralized storage facility in Surabaya City. And then there will be auction arranged by this storage facility, and then there will be potential buyers who will do the recycling to produce products to be marketed. And I would like to give a bit comment here, please. Next, please. It is very common here that small size e-waste normally go to disposal facility of the municipal solid waste, and this should be stopped. And all offices, including universities, government offices and schools, should be provided with drop box to collect all these small e-waste, and this small e-waste should be placed together with the other large e-waste large size e-waste in the storage room. Next, please. And I would classify the activities in the users of the electronic products. They are under the umbrella of specific waste management regulation. But those which is done by the recyclers, please. Next, please. This should be under hazardous waste management regulation. So there are two different regulations. which works for the management of e-waste actually. Next, please. So how about e-waste handling in ITS? As a state university, ITS should follow, still follow, because the regulation on e-waste management has just been established in 2020. So ITS, I think, still follows the regulation for use government asset management for handling the waste, the e-waste. And we observed 7 departments from a total of 28 in 2016. Next, please. These are the e-waste of the e-waste types that we observe in our department. And we had 82 kinds of e-waste with a total weight nearly 400 kilograms. And this e-waste has been kept in our department for more than 10 years. Next, please. And also in the other department, the other 6 department with less e-waste generation, indeed generate also less amount of e-waste. So the highest generator is electrical engineering, because the number of students also the largest, more than 800 students in this department. So we noted that there are not less than 577 units of e-waste with a total weight of more than 10 tons. Next, please. So the storage time vary between the new built departments like biology and geophysics. At the time, there's quite new departments. So the storage time is from a few years to more than 10 years. So this is one of the problems in e-waste management. Next, please. So this is the storage condition in marine engineering department and environmental engineering. And we estimated that the e-waste generation from all departments by 2016, total units is 1,289, total weight is 16 tons. Next, please. So how about e-waste management in school? So we observe 12 schools here, state and private. Next, please. And we observe that, next, please, the generation of e-waste in higher level of education of the schools generate higher e-waste quantity. Also the private schools, next please, the private school generate a higher e-waste compared to the state schools. Next please. So these are the e-waste types. That the gray one is IT and telecommunication equipment like CPU, printer, keyboard, and scanner. And the black one is actually screens and monitors. And the white one, these are the small equipment like speaker, amplifier, regulator, and others. Next, please. So this is the storage condition of the e-waste in each schools. Next, please. And they kept the e-waste from 1 to 15 years, depend on the schools. And the state school, the government school, the public school should follow the strict regulation for government asset management for e-waste. But for private school, they have more simple management stages. So if the e-waste, if the electronic devices cannot be repaired, the large e-waste go for inventory listing and then stored. And after storing, they will be sold to the collectors. But the small e-waste normally they dispose it together with other municipal solid waste in the public facility. Next, please. So again, we better stop the disposal of the small e-waste to the common municipal solid waste facility. And next, please, we should provide drop boxes for storage. Next, please. And to avoid the handling in the e-waste to the illegal collectors, it will be best if the local government can provide proper collection facility for e-waste. Next, please. So I would like to end my presentation with some closing remarks. The first one, Indonesia faces many challenges for establishing proper e-waste management system. Good research are required for building a good database to support workable and proper e-waste management, indeed also for recovery of the precious materials and to support the circular economy. E-waste generators generally keep the e-waste at source for a long time, and this may release hazardous substances. The third remark is the e-waste management should be evaluated and improved. A good collection system is urgently needed. And the last one, because it also occurs in ITS, is government institution, mechanism for managing e-waste originated from government funds should be simplified. Status of the centralized storage facility for government used asset should be upgraded to a specific waste collection facility, which should follow the regulation for specific and e-waste management. So next, please. Thank you very much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor Yulina, for sharing the knowledge with us. Ladies and gentlemen, I would like to take a couple of minutes to deliver the key points from presentation from Professor Yulina in Bahasa Indonesia. Bapak dan Ibu, saya akan menyampaikan key points atau poin-poin penting yang sudah dipresentasikan Profesor Yulina. Yang pertama adalah saat ini Indonesia menempati peringkat ke-7 dalam pemproduksi elektronik waste atau limbah elektronik, dengan jumlah yang tercatat pada tahun 2021 adalah sebesar 2 juta megaton limbah elektronik. Kemudian sebesar 56% limbah elektronik saat ini diproduksi di Pulau Jawa, yang merupakan pulau terpadat di Indonesia. Kemudian selain itu, beberapa hal yang penting adalah saat ini Indonesia menghadapi banyak tantangan untuk membangun sistem pengelolaan limbah elektronik yang tepat. Penelitian yang baik diperlukan untuk membangun basis data yang kuat untuk mendukung sistem pengelolaan limbah elektronik yang dapat diterapkan dengan tepat. Masyarakat yang memproduksi limbah elektronik cenderung menyimpan limbah elektronik di sumbernya dalam waktu yang cukup lama. Ini yang tidak disadari karena mungkin ini bisa melepaskan senyawa yang berbahaya. Kemudian pengelolaan limbah elektronik seharusnya dievaluasi dan ditingkatkan. Sistem pengumpulan yang baik saat ini sangat dibutuhkan. Yang terakhir adalah mekanisme pengelolaan limbah elektronik yang bersumber dari dana pemerintah harus disederhanakan. Status fasilitas penyimpanan terpusat untuk aset yang digunakan pemerintah harus ditingkatkan menjadi fasilitas pengumpulan sampah khusus atau TPSSS B3. Baik, Bapak dan Ibu, kami persilakan untuk meninggalkan pertanyaan di chat box. Setelah presentasi dari speaker kedua, kita akan melaksanakan sesi diskusi. Again, thank you very much, Prof. Yulina, for our awesome presentation. Now we move on to the second speaker. We will listen to the presentation from Professor Ching Hua Lee from Daye University with the title of Electronic Waste Management and Treatment in Taiwan. But before that, I will read out the curriculum vitae from Professor Lee.
Hello.
Yeah, good morning, Professor.
Good morning, everybody. Can I share my screen for my presentation?
Yeah, sure. Professor Lee, I will take a moment to introduce yourself first. So, everyone, Professor Lee is distinguished professor in Daye University. His research field is electronic waste, hazardous waste, and also material recovery. I would like to invite participants to submit your question in the chat box, and then we will cover all the questions during the discussion session. So Professor Lee, you will have 25 minutes for the presentation. I will give the time for you now. So the time is yours. Thank you.
Okay, first, can I share my screen? I don't know how to do it.
Yeah, Professor.
Okay. Oh, share my screen.
Yeah. Which one is?
I don't, this is the first time I use Zoom, so I not know how to do it.
Yeah.
Yeah.
Okay.
Professor Lee, may I help you?
Yes.
So maybe you could open the file of the PowerPoint presentation that you use.
Okay.
We already see your desktop at the moment.
Okay. Can you see?
Yeah, we now see the PowerPoint presentation.
Okay. Can you
and
see
it's
now?
full screen now. Yes, it's perfect, Professor.
Okay, I will start my presentation. Let me set out the time. So you will remind me for 25 minutes? Okay.
25 minutes, yes.
Okay, so my name is Qinghua Li, and it's my honor to participate in this webinar. And today's my topic is e-waste management and the treatment in Taiwan. Okay. And we can say that electronic device is essential for modern society. I think now these days, everybody rely on electronic device. So there are going to be a lot of the e-waste will be generated. And this e-waste should be treated properly. Otherwise, it may cause environmental pollution or damage. And from my point of view, the e-waste can be divided into two categories. The first one will be household e-waste, such as the computer, refrigerator, etc. You can find at your own home. And this kind of household e-waste, usually we call it as the waste electrical and electronic equipment, and with the short name of WEEE. And the other type will be industry e-waste. And the industry usually will be generated by the private company or producer. For example, the commonly found will be integrate circuit or printed circuit board or wafer, etc., etc. And because Taiwan is very strong in semiconductor, so in Taiwan we can find a lot of industry e-waste. However, for today's speech, I'm going to focus on the household e-waste, which is WEEE. And according to Taiwan's law, it is government responsibility to treat household e-waste. However, for industry e-waste, it's the private company or private producer responsibility to treat it. So we are only focused on the WEE, which is household e-waste. And there's a definition for EEE. And this definition is given by EU directive on WEEE. So I'm not going to go detail for this definition. But if somebody is interested in WEEE management, and this is very important reference for you to look at it. There are many management or treatment technology are given in this directive. Actually, in Taiwan, I think in many times we have followed this directive. And the reason why WEE treatment has drawn great attention worldwide is mainly because WEE contain a lot of variable material. For example, you can find gold, silver, metal, or you can find some kind of recyclable plastic or even glass in the WEE. However, WEE also contain a lot of hazardous material. For example, in the PCB, you can find the lead, which is heavy metal, toxic heavy metal, exercises, and also you can find the mercury in the battery, you can find the lead in CRT. So because WEE is a very good recyclable waste. However, if you don't treat hazardous component carefully, then during the WEE recycling process, it may seriously pollute the environment. So that's why we need some kind of management or a guideline for WEE recycling. And this is the one example. This is CRT. In the old TV or old computer, you can find a CRT. And this is a component analysis of the CRT. For example, in the funnel gas, which is this part, in the funnel gas, you can see that about 22 to 28% is lead oxide. So this may seriously pollute environment. And usually funnel gas has no use, so people may throw away. So that's not good. And in modern monitor, now we switch to LCD. LCD looks very thin, however, it's also many layer for LCD, and this is the layout for the LCD. And I think the hazard material will be found in the liquid crystal, because liquid crystal contain many polymer. One of them are benzene. Benzene is the toxic, and it's a cancer-causing material. So we may have to treat liquid crystal carefully. Also, inside the LCD, there is an ITO layer, which contain the variable metal of indium. And this indium has a price similar to silver. So if you can recover the indium from the LCD, then you have some kind of variable material for sale. So in order to treat WE properly, Taiwan EPA has issued a regulation regarding on the WE management. And this regulation is issued in the Article 15 of Waste Disposal Act. Okay, and the Waste Disposal Act is the mother law for waste treatment or disposal in Taiwan. Then under this article, it says if a household waste, I have to emphasize this article only apply for household waste, not for business waste. Okay, if a household waste have these following 4 criteria, then the government may announce this household waste as the mandatory recycling waste. Okay, the first criteria will be if the waste is difficult to be collected or disposed of, such as TV or air conditioner, because it's too heavy to collect. And the second one will be does not contain readily decomposable substance, such as like this PET bottle or aluminum can, because it will not disappear for a long time. And also, if a household waste contains hazardous substance, such as the battery contain mercury, or the frozen lamp contain the mercury, then it will meet this criteria. Or any other household waste can be recycled. It will also be included in Article 15. So if any household waste can meet one of these 4 criteria, then it can be announced by Taiwan EPA as mandatory recycling waste. But I have to emphasize, it can be, not must be. So not all the household waste meet this criteria will be announced. So far, there are 33 items were announced as mandatory recycling waste, which are shown name as MRW. So if a household waste was announced as MRW, then this waste must be treated by recycling process, and it cannot be sent to the landfill or incinerator. Okay, this is the mandatory recycling waste mean. And so far there are 33 items was announced according to this law. And these 33 items can be divided into two categories. One, the first one we call object. So such as the tire, car was specified as object type. And the other way container, just like a PET bottle, aluminum can, steel can, or any kind of container would belong to this type. And in order for the ordinary resident to recognize what is the MRW, what is not, the Taiwan EPA require or ask the producer to put on this recycling label. Okay, so that means if a resident, if they find their product has this kind of label, we call recycling label on it, then that means if the resident finish this product, when they throw away, they have to follow the mandatory recycling waste law. But and this example is a Tetra Pak, right? So in the Tetra Pak, you can see this symbol. So in most of in Taiwan, most of the container have this kind of label, and the resident will know this is a recyclable waste, or we can say it's a MRW waste. Okay, as I mentioned, for household waste, it's government responsibility to treat it. But if the household waste meet those 4 criteria, then the government say the government will not take responsibility. Instead of the manufacturer or the importer of this product should take responsibility. And what kind of responsibility they will take? Very simple. They just have to pay the recycling fee to a recycling management fund. And this fund is established by Taiwan EPA. Okay. And with this fund, this fund usually collect a huge amount of money. So sometimes we just call it a big fund, since it has a huge amount of money inside it. Then with this fund, then the EPA can subsidize the certified recycler whenever or whatever, when they recycle the WEE or any other substance, then they can get the money. So since there's an incentive for Recycle to do the recycling, so it will help the WE recycling system to work well in Taiwan. And usually we call this kind of system or program, we call Producer Responsibility Recycling Program. Or somebody may call it Extended Producer Responsibility Program. Okay, and we say call it PRRP. Okay, this is in Taiwan's law. And as I mentioned, there are 33 items was mandated to be recycled. And among them, there are WEE. Okay, and there are 2 categories for WEE, which was announced as MRW. The first one will be home appliance, that including the TV, refrigerator, washing machine, air conditioner, and the fans. Sometimes lighting source like a frozen lamp will also can be classified in. But traditional, we are talking TV, refrigerator, washing machine, air conditioner. Okay. And the second type will be IT product like a computer, printer, notebook, etc. And these 2, although they belong to WE, but because the manufacturer who pay the recycling fee are different, so they are right now there are 2 different groups to conduct the W recycling. Okay, and I think this is the stated day when we start in Taiwan to do the W recycling, and you can see that for appliance, it started from 1998, so that's about 24 years ago, right? A long time ago. And for IT product is also started from 1998, so that's also 24 years ago. And this original announced item, and later on, gradually they will increase more item. Okay, you can see now in 2001 they increased the printer. Okay, and they increase some kind of light tube, and keyboard, fan. So it is not start in the beginning to including all the WEE. So it will gradually increase. And I think the many is because we don't know in the beginning whether it's work or not. So after it goes smooth, then it will gradually increase more item. And this is the important event for IT recycling. That means for computer with squad computer recycling. And you can see this law, the PRP Producer Return Program, stay in the law on 1988. So it's about 34 years ago. So that means in Taiwan, we start this kind of producer responsibility return program for WEE, not for WEE, for household waste, started from 34 years ago. But not only after 10 years implement this kind of principle, then after 10 years, then we start to regulate, include the squad computer or the appliance. So that means WEE recycling is started from 24 years ago. And if you have time, you can look at this event. Okay, so it takes time to implement this kind of WE recycling, not just study at the one time. Sometimes you have to inform many people. You have to inform the manufacturer, especially WE manufacturing in Taiwan is very strong because that's a big industry. So the government may need do some negotiation with this kind of manufacturer importer to get their approval or consumption. Otherwise, the system cannot work. Okay, this shows the financial mechanism behind the WEE recycling program. There are two important fees involved in this system. The first one will be the recycling fee, which is paid by manufacturer or importer. Okay, and we can see that the recycling fee charged by set. Okay, so if you produce one set of TV, then the manufacturer had to pay 150 in 1998. That's NT dollar. And this is a big TV, small TV. You pay a different amount of money. And for latest today, I mean this year, okay, if you produce or import one non-LCD TV, that means a CRT TV, okay, you have to pay. So the manufacturer had to pay 397 NT dollar. And if you produce green TV, then you can pay less. That's 378. Okay, and what do you mean green product or green TV? So if you can get this kind of label, this label is issued, for example, this is a green label issued by EPA. This is energy conserve label, maybe issued by, we have some kind of energy division, right? And this is water saving, etc., etc. Anyway, if you can produce equipment with some kind of environmental label, then you can pay less money. So this will encourage the manufacturer to produce environmental friendly equipment. Okay, and this is for refrigerator, washing machine, air conditioner. You can take a look. And the other fee involved is the subsidy. Okay, because finally some recycler had to do the WE recycling. Otherwise, the WE problem will not disappear, will not be solved. Okay, so if you are certified recycler, then after you treat one set of WE, for example, if you if you are certified, first you have to be certified first. If you are certified recycler, if you trade one set of TV, now I see right now you can get 284 NT dollar per set. Non-LCD, that means CRT. They also there's a different fee for LCD TV, but there are too many, so I did not include that information. And this part is because during the collection, sometimes the WE will be broken. That means some parts will disappear. Okay, if you collect it's not the intake WE, then you will get less money by weight. You may lose for example, the casing, or you may lose the CRT, but you still can get partial money. Okay, so this is for non-intake WE equipment. Okay, you can get different money. Okay, this is for the appliance, right? Okay, next one for IT equipment, the same. If you have PC, monitor, okay, printer, okay, similar philosophy. For manufacturer and importer, you have to pay this amount of money. Also, if you can produce green IT equipment, then you can pay less money. And this is for certified recycler. You can get subsidy from the recycling fund if you can treat the one set of WE equipment. I think this is this financial system is important for the WEE recycling system in Taiwan now. Okay, as I mentioned, only the certified recycler can get the subsidy. Before this system, there are already many recyclers exist. They treat WEE, but the problem is they did not treat properly. Okay, so in order to get a subsidy from EPA or from the Recycling Management Board, then you have to be certified. Okay, so that means EPA had to announce a treatment guideline for squad IT or squad appliance. Okay, then with this guideline, then the recycler can build their certified recycling plan. So somebody had to do this kind of guideline. And about 20 years ago, I have conducted a project for EPA. So in that project, I was in charge of to draw the guideline, treatment guideline or recycling guideline for IT recycling. And this is the guideline I drew before. That's about 20 years ago. So right now they change it. I think there's some change. I did not follow now. And in this guideline, we are focused on the hazardous material, not the variable parts. Because the variable parts, the recycler already know how to do it. But we have to mention or where to specify the recycler to treat the hazardous parts or hazard component properly. Okay, for example, this line, okay, this guideline, all the mercury containing parts must be removed by non-destructive means for proper treatment. Okay, so you have to take care of the mercury parts, for example, the battery or some kind of relay. Okay, and the CRT must be ventilated. Okay, and the lead content, that's a funnel gas, had to be treated properly. Okay, and inside the liquid LCD, because they contain the benzene LC, so we have to take care of it properly. Okay, and another one is plastic which contain flame retardant or bromine should be treated properly, because usually plastic casing is considered recyclable material. However, there's a bromine inside. If you did not recycle properly, the bromine may cause the damage to the environment. Okay, so there are many concerns about hazardous component. So if the recycler can take care of this hazardous component concern, then they can get approval or they will be certified. After they certify, then they can get the a subsidy from the EPA management fund. Okay, this is the hardest component when I do the how to say treatment guideline. For example, this casing which contain the bromine material and the funnel contain lead, and also the fluorescent powder inside the CRT contain heavy metal, and this mercury relay, and this capacitor contain the PCB, so it's also hazardous. And for example, for LCD during the dismantling, in the back, this is a backlight, right? The backlight contain the mercury, so you have to treat it carefully. And this battery, etc., etc. And this is a picture for certified recycler. Okay, this is I think the picture. I think you can find it in our EPA website. Okay, okay. Because of time, I think I don't know how many time I have. Okay, and another important task should be done in this system is the auditing, because I mentioned the recycler will get the subsidy by set. So if they treat one set, they can get the one set of money. But how do we know they treat one set or two set? Because there's some kind of wrongdoing. Some people, some researchers may say, I only treat one set, but I report as treat two set, they will get more money. So in order to prevent this kind of wrongdoing or cheating, so we have developed an auditing system. Mainly is counting the key component parts. For example, when you treat one CRT, you will get this kind of parts. If you treat one refrigerator, you will get maybe compressor. So each WE will have unique one key component. So after we treat it, we will count it. So EPA will have a system to count this key component. And you can see there's a pen, right? So that pen doesn't mean if you paint it, doesn't mean it has been counted. Okay. And with the technology improvement now, we are using the CCTV long time ago. So the EPA can use CCTV to control. Anyway, this kind of auditing system is very time consuming and how do you say, money consuming. Sometimes for some items, the auditing cost might higher than the subsidy price in order to prevent cheating. Okay, so far this is the distribution of the WE recycler. You can see right now we are 12 for appliance, 16 for IT. But this is all information. I did not do the update. Just get a picture. And then many W recycler, they can do both. So in the meantime, they are doing the IT. Also, they are certified for appliance. Okay, for the summarization, I use this diagram to explain. Okay, for Taiwan WE management system. So EPA is in charge of the whole system, and the EPA organizes the recycling fund management board. Okay, the RFMB is authorized by EPA to conduct all this system, and this board is considered semi-official government. Okay, it is not a government employee. It's partial employed by government. Okay, and the manager board will select or approve the certified WE recycler based on the treatment guideline. Okay, and the board will educate the people because the WE is produced generally in the ordinary house, so they have to promote WE to be sent to the collection point, and from the collection point they will send to the recycler, certified recycler, and after the third-party auditor, the third-party auditor will go to the recycler to do the auditing, just like checking the key component or by using CCTV. Then they will give the report to the managing board, okay, the audit report. Then after receive the report, they will ask the managing fund to pay the subsidy to the recycler. And the managing board also will form a fee committee, and this fee committee will propose a financial recycling fee to the EPA, and the EAP will tell the manufacturer or importer to pay this recycling fee to the managing fund. Okay, so anyway, I think because time limit, so this is a basic WE management system in Taiwan. Okay, that's all my presentation. Thanks for your attention. Thanks.
Thank you very much, Professor Lee, for sharing the knowledge with us. Really appreciate the case study that you brought from Taiwan. Before we go to discussion session, I would like to deliver the key points in Bahasa Indonesia to our participants. Bapak dan Ibu, saya akan menyampaikan beberapa poin penting dari presentasi yang sudah disampaikan Profesor Lee. Yang pertama adalah kita tahu limbah elektronik dapat berasal dari rumah tangga dan industri. Kemudian dari komponen limbah elektronik ini sebetulnya terdapat dua komponen. Yang pertama adalah komponen yang memiliki nilai atau valuable, dan yang kedua adalah komponen yang berbahaya atau hazardous. Pemerintah Taiwan sendiri ya, diinisiasi oleh Departemen dari Lingkungan Hidupnya menerapkan program daur ulang tanggung jawab produsen, atau di kita juga ada IPR, di mana produsen dan importir harus membayar biaya daur ulang ke dana pengelolaan daur ulang berdasarkan jumlah penjualan atau impornya. Pendaur ulang limbah elektronik bersertifikat juga bisa dapat subsidi oleh dana manajemen daur ulang untuk jumlah daur ulang yang sebenarnya. Nilai-nilai yang ditetapkan untuk pembayaran ini atau subsidinya bisa dipengaruhi oleh apakah barang elektronik tersebut mendapatkan label green label atau environmental label. Kemudian selain itu, recycler juga perlu mengikuti treatment guidelines yang sudah ditetapkan oleh pemerintah untuk bisa masuk dalam skema ini. Beberapa limbah elektronik yang wajib untuk didaur ulang dari rumah tangga, contohnya adalah TV, kulkas, mesin cuci, AC, dan kipas angin. Dari industri, salah satu contohnya PC, lainnya ada laptop, printer, dan lain-lain. Seperti itu. Bapak dan Ibu, saya persilakan untuk meninggalkan pertanyaan pada kolom chat yang ada pada control panel Zoom. So, again, thank you very much, Professor Lee, for our awesome presentation. Now we move on to the discussion session for the first session. This discussion session is aimed for the presentation from Professor Yulina and also Professor Lee. My colleague will help me to present the question that have been submitted by participants. Okay, so the first we have question regarding the EPR. In the electronic waste management in Indonesia, Professor Yulina, are you still with us?
Yes, I'm here.
Okay. Yeah, okay, thank you. So this first question is directed to Professor Yulina. In the electronic waste management in Indonesia, does it involve the industry manufacture? And how about in Taiwan? So I guess this is also for Professor Lee. So please, Professor Yulina, you may start.
Shall I answer it in Indonesian or in English? Because many participants want to have it in Indonesian.
Yeah, sure. You are welcome to deliver it in Bahasa Indonesia, and then I can translate it in English.
Okay, that's okay. Thank you for the question, Pak Imam. The e-waste management in Indonesia actually should involve the industries because this has already mentioned the EPR. The EPR approach has been mentioned already in the Solid Waste Management Act in 2008, number 18, 2000 Act. So industry, the producer is responsible to manage the waste coming from the products. So I think it has already been stipulated, but the realization, this still need guidelines. So in this case, Department of Industry as well as Department of Environment and Forestry should sit together and make workable guidelines for conducting the EPR. Parts of some industry I think have done the EPR. Like if we buy TV, then the old TV can be given to the shop and the shop will give us some money. So it's a kind of EPR. So I think the question is answered by Imam that manufacturer or EPR should be involved in the e-waste management. Thank you.
Ya, Bapak dan Ibu tadi sudah disampaikan oleh Bu Yulina, di Indonesia sendiri kita sudah memiliki apa yang disebut sebagai EPR, Extended Producer Responsibility, serupa dengan apa yang ada di Taiwan. Namun memang yang saat ini belum ada adalah panduannya atau guideline-nya, yang saat ini masih kita tunggu. Untuk implementasinya sendiri, kita juga akan menunggu dari Kementerian Industri, kemudian juga Kementerian Lingkungan Hidup, untuk bisa merealisasikan EPR yang ada di Indonesia. Beberapa contoh yang sudah ada memang, contohnya adalah apabila kita membeli barang elektronik seperti TV, kita bisa mengembalikannya ke produsennya untuk limbahnya. So, Professor Lee, you may also add from the case in Taiwan, please.
Okay. In Taiwan, the e-waste, maybe I can say there are 3 different kinds of e-waste. The first one is I mentioned, if it is announced by EPA as mandatory e-waste, mandatory recycling e-waste, then the manufacturer of this electronic device should pay the money to the EPA. That's it. If it's MRW, the manufacturer or importer pay the money, recycling fee to EPA. That's the first one. And if it is a household e-waste and not announced by our EPA, then the government has a responsibility to take care of it. For example, cell phone. Cell phone is not announced as the mandatory recycling waste, etc. Then the government has a responsibility to take care of it. However, if the e-waste is not belong to household e-waste, it's an industry e-waste, then the manufacturer has a responsibility to treat it, but not pay the money to EPA. They have to find their own way to treat this kind of e-waste, such as IC, printed circuit board, etc. Yeah, thank you.
Yeah, thank you, Professor Lee, for the answer. Bapak dan Ibu, seperti yang disampaikan Professor Lee bahwa di Taiwan terdapat beberapa jenis limbah elektronik. Kemudian tadi juga disampaikan bahwa beberapa jenis limbah elektronik tersebut memang kategorinya wajib untuk di-recycle, dan dalam hal ini ketika diwajibkan, limbah elektronik akan ditangani oleh DLH-nya atau EPN-nya mereka. Apabila limbah elektronik tersebut tidak termasuk dalam kategori mandatory atau wajib, maka pemerintah setempat perlu memberikan mekanisme untuk recycle-nya atau mengelolanya seperti apa. Kemudian untuk dari industri, memang industri beberapa limbah elektronik yang dihasilkan tidak diwajibkan oleh pemerintah untuk recycle, namun industri itu sendiri yang wajib untuk mengelola atau mengolah limbah elektronik tersebut, selain apa yang sudah disampaikan pada slide yang awal tadi. Okay, Professor Lee and Professor Yulina, thank you. Now we move on to the second question. This question is from Muhammad Dhani, PT Smart. In the new regulation for electronic waste,
how to manage the EPR?
Indonesia is quite common to do that. And how about in Taiwan? Is it allowed to sell the electronic waste to the informal sector? Maybe Professor Lee could start.
Okay. As long as it is considered as a waste, then you cannot send to the illegal, illegal recycler. They must send to certified or approved recycle company or to the treatment company. So that's the intent generally. So any waste should not be sent to illegal treatment facility. I don't know whether I answered the question or not.
Ibu Nisa, Ibu Nisa, are you still there? Okay. Maybe have a problem with the connection.
Yes.
Yeah. Okay. Ibu Nisa. Okay. Maybe we wait for Ibu Nisa for coming, but thank you very much, Professor Lee. Regarding to the regulation in Taiwan, so it seems that it's prohibited to send to the informal, large, or small recycling enterprises. And Ibu Yulina maybe can add it about the new regulation, because we have the new regulation actually for not for the e-waste but for the hazardous waste, specific waste. I think about this one, Bu Yulina. Yeah. Ibu also maybe can answer by using bahasa. It's also can Ibu. So I will be then translate in English.
Okay,
Yeah.
it's easier for me because
Yeah.
well, Mas Dani, is it Mas Dani who is from ITS then doing the?
I think yes, Ibu. I think yes,
Halo,
this is
Mas
our
Dani,
alumni.
Ya, oke, Bu Arman. Jadi Mas Dani, di dalam yang kita punya adalah peraturan tentang pengelolaan limbah spesifik dan pengelolaan limbah B3. E-waste termasuk di dalam peraturan tentang pengelolaan limbah spesifik PP nomor 27 tahun 2020. Dan tadi telah saya jelaskan bahwa kegiatan pengepul di dalam merecycle itu jatuh ke dalam peraturan tentang pengelolaan limbah B3. Jadi bukan lagi pengelolaan sampah spesifik. Pengelolaan sampah spesifiknya ada di alur pada penghasil, ya, sampai TPS-SS B3. Nah, jadi kegiatan recycling itu masuk ke dalam ranahnya pengelolaan limbah B3. Saya kira nanti Pak Gunawan akan menjelaskan lebih detail tentang hal itu ya. Jadi begitu keadaannya, Mas Dani. Kemudian pengepul yang diharapkan menangani limbah e-waste ini untuk recycle adalah tentu saja karena terkena aturan tentang limbah B3 dia harus berizin, seperti itu. Terima kasih Bu Arma, mudah-mudahan menjawab.
Terima kasih Bu Yulina. As mentioned by Bu Yulina, Pak Dani tadi sudah disampaikan ya, because we have a different regulation for the collecting of the hazardous waste in Indonesia. We have for the hazardous waste not only for the specific waste, so it is based on that regulation. And later on, we really hope that Pak Director Pak Gunawan will become and also explains about this one. Thank you. And Ibu Nisa, you already join with us? Ibu Nisa? It's not yet. Okay, we will continue with Ibu Nindi because we also run off time. So for this third one, this is also a question to Ibu Yulina and also Professor Lee about the possibility that e-waste will be dumped in the ocean, because not all the e-waste will be dumped in the landfill. How about that? And the second one about the participation of the community, because right now the community trend to change of their electronic waste, especially for the mobile phone, because they follow the trend. And how about this opinion from the distinguished professor that how we dealing with this kind of participation of the community? So please, Professor Lee and Professor Yulina. Mungkin Bu Yuli dulu?
Saya dulu ya.
Ya.
Answer it in bahasa Indonesia. So Mbak Nindi juga alumni ITS ini. Jadi saya kira dilarang ya kita membuang sampah sembarangan. Jadi seperti tadi saya jelaskan, re-waste itu kan specific waste. Jadi penanganannya harus memenuhi ketentuan tentang specific waste. Ya harus ditampung, kemudian dibawa ke TPSS limbah B3. Ya, dan TPSS limbah B3 kan juga harus terdaftar ya di pemerintah daerah, sehingga penanganannya itu karena sudah specific waste juga harus lebih hati-hati, jadi tidak boleh dibuang ke laut. Terus apalagi ini? I think that's my answer, Bu Warma.
Ya, terima kasih Bu Yulina. Thank you very much, Bu Yulina. It's already answered that it's prohibited to dump in the ocean. And how about Professor Lee? Do you have opinion for the second one, Professor Lee?
Okay, in Taiwan, the Waste Disposal Act, it says that there are two ways for waste final disposal. The first one will be landfill. The second one will be ocean dump. So ocean dump is one of the options for waste final disposal. However, so far, no ocean dump can be allowed in Taiwan. I think basically is that if you dump the e-waste in the landfill, your landfill usually is careful control. So if there's hazardous substance leak, then it still will be contained in the landfill ground. However, if you dump in the ocean, if the hazardous substance leak, then it may affect the ecology. For example, the fish may eat this kind of hazardous substance, and then human eat the fish, then the human will get disease. So I think the Taiwan government is very carefully about the ocean dump. So far, no ocean dump happened in Taiwan. Okay, that's my question. Yes.
Yeah. And how about the opinion for the young generation, especially that usually will be change their mobile phone very often?
I don't know. I think this kind of young generation, I think maybe their parents should control their how the allowance for buying the mobile phone. I don't know. Yeah.
Yeah. Yeah. Okay, Professor. Thank you very much for the answer. And we still have maybe two questions. The first one is for Professor Lee, of course, about the how to monitor extended production responsibility in Taiwan. So, Professor, could you answer this question? Hello?
I did not read the first one. Is waste management in the I think I still see that.
How to monitor the EPR of e-waste in Taiwan, Professor?
How to monitor? Because I mentioned the EPA has organized a management board, right? So the management board is in charge of the whole WEE management system. So then there are many many organizations involved in this system, and all these organizations have to file a report to the management board, and the management board will summarize the report to EPA. So I think that's how EPA can monitor the WE management system in Taiwan. And also the local government. In the local government, we also have some kind of environmental protection bureau. The environmental protection bureau also have the manpower to go into this kind of WE recycle to check whether they meet all kinds of environmental regulation. For example, water pollution, air pollution, they will check. So I think right now the system is there, and there are many kind of checking mechanism behind it. So probably not too much email problem so far for W recycling. Yeah, that's what that's my opinion. Yeah, thank you.
Yeah. Thank you very much, Professor Lee. Jadi tadi sudah disampaikan Bapak bahwa memang ada semacam departemen atau agensi yang juga mengawasi berkaitan dengan hal tersebut, begitu berkaitan dengan extended production responsibility yang dilaksanakan di Taiwan. So we thank you very much, Professor Lee, and we already have Ibu Ainul in here. Ibu Nisa, could you lead again for the discussion? We still have one discussion.
Yeah, sure. Thank you very much, Warma. Apologies for the technical problem. I guess this is always the case when we have an online webinar. Yeah. So, are we cover all the question already? Oh, we still have one question. Huh? The last question. Yeah. For electronic waste management, it is better to cooperate with the producer. They are obligated to provide electronic waste collection facilities in the community so that when the electronic waste is disposed of TPS as B3, the amount will be reduced. There needs to be a government policy regarding this matter. This is also the case in Taiwan, Professor Lee.
And I don't quite understand. I don't quite understand the question. Yeah, but as I mentioned in my presentation, if the manufacturer will produce some kind of product which is regulated by Taiwan EPA as mandatory recycling waste, then the manufacturer had to pay the money to the EPA to help establish the recycling event. So
yeah, is the collection point also provided by the government, or is there or there is only a centralized for the collection?
You mean for the collection point? The government only. I don't know whether my answer is correct. So far, the government only subsidize the recycling plant. They did not pay the money to the recycler collection point. So the recycling company get a subsidize with this money. They will pay for the collection to help them to collect the WEE.
Yeah.
Okay, that's it.
So it's directly to the recycling center.
So sorry, I did not hear you.
See mechanism. How do people pay, or how do the sector will pay for the recycling fee?
Sorry, your connection is not good. So I did not hear you very clearly. Sorry.
Yeah. Again, regarding the recycling fee, Professor Lee.
Yes.
Is there any mechanism how government withdraw the money?
Sorry, I lost you again. I did not.
Yeah. I think the connection is not good enough for Ibu Nisa.
Sorry.
Yeah. So, Ibu Nisa, could you hear us?
Now do you hear my voice clearly, Professor Lee?
Yes, for me, yes.
It's better now.
Now it's clear.
Okay. I will turn off my video for a moment to improve the connection. Earlier, regarding the fee mechanism, how do the government withdraw the money or collect the money from the manufacturer, also importer? Is there any specific mechanism for the fee collection?
Yes, because according to this law, the manufacturer and the importer must pay. If they don't pay, they were against the law. so they have to pay if their product was announced as the MRW, mandatory recycling waste. And in order to calculate the recycling fee, so the EPA has organized a fee committee. In this fee committee, you are including the manufacturer and the importer also. And they will include in this fee committee, they will include some kind of scholar, and those scholar will calculate a basic fee, and then they will discuss with the manufacturer. So whenever the fee sent out by the fee committee, usually the manufacturer will accept this fee, and by law they have to pay. So that's government's law. Yeah.
Yeah, thank you very much for the clarification. Ya, Bapak dan Ibu tadi sudah disampaikan bahwa sudah ada mekanisme untuk penarikan biaya untuk recycling tersebut untuk importer dan juga untuk manufacturer. Dan apabila mereka tidak membayar, maka mereka akan dikenakan denda nantinya untuk daur ulang limbah elektronik ini. Begitu. I think we have covered all the question, and unfortunately we need to move on to the second session because of the limited amount of time. Thank you very much again, Professor Lee and also Professor Yulina, for sharing the knowledge with us for the case study in Indonesia and also in Taiwan. I really appreciate again your time for joining today's webinar. Thank you very much. Maybe we could give a round of applause using the Zoom icon. Thank you.
Thank you.
Thank you.
Yeah.
Thank you, Mbak Nisa.
Thank you very much, Bu Yulina and Professor Lee.
Sama-sama.
Thank you.
Okay. Ladies and gentlemen, we now move on to the second session of today's webinar. In the second session, we will listen presentation from two presentations. The first is from the Director of Hazardous Waste of Ministry of Environment and Forestry in Indonesia, Bapak Insinyur Ahmad Gunawan Wicaksono. And then the next presentation, we will listen from Dr. Jenny Lee from University of Vidya Mandala. But before that, again, just for housekeeping, if you have any question, you could type the question in the chat box in the Zoom control panel. You could type in English or in Bahasa, that's fine. We will try to cover all the questions during this discussion session. And also, please make sure that you mute your microphone during the presentation session. Bapak dan Ibu, saya persilakan nanti untuk menyampaikan pertanyaannya melalui kolom chat dalam bahasa Indonesia maupun dalam bahasa Inggris, boleh dipersilakan. Okay, now we are heading to the first presentation in this second session.
Bu Nisa, maybe Ibu Jenny first.
Okay, we will start with a presentation from Dr. Jenny Lee. I will read out the curriculum vitae first from Dr. Jenny Lee from Vidya Mandala University. So Dr. Jenny Lee is a lecturer of the Chemical Engineering Department at Vidya Mandala Surabaya Catholic University. She holds bachelor degree from Vidya Mandala Surabaya Catholic University and a doctoral degree from National Taiwan University of Science and Technology. Also engineering professor from Vidya Mandala Surabaya Catholic University. Her research field cover electronic waste, metal recovery, subcritical water extraction. Okay, now I will hand this time over to Dr. Jenny Lee. You will have 15 to 20 minutes for the presentation. I will make a reminder in the end. Yeah. Okay, now the time is yours, Dr. Jenny Lee.
Okay, thank you very much, Nisa, for the nice introduction. Can you hear my voice and see my slides?
Yes, we can see the slides clearly.
Okay, let me start. Good morning, everyone. Thank you very much. I thank STIC and the committee for inviting me to this amazing webinar and talking about the e-waste management, which is, I think it is still taboo in Indonesia, right? And I would like to present the e-waste as the open. What is it? So I think he has been introduced me to briefly introduce myself again, and I'm a lecturer in media management, and I just get my PhD here in Taiwan University and Technology by Professor J, the head of, and actually, and about the recovery from E. And which I fit with my study. And mentioned that Indonesia, from this year, you can see that Indonesia is one of top producers of e-waste in 19. It contributes to 1.1 million metric tons e-waste globally. But according to the Professor Yulina, actually Indonesia reached 2 million tons of e-waste in 2000. And on this figure, and see that metal then reveals about 60% the completion of the of the it will I think good.
Jenny, maybe you could turn off your video for a moment so we could hear your voice clearly, because your voice cracking.
Thank you for reminding me. Can you hear my voice clearly?
It's much better now.
Okay, thank you. Okay, so it is fascinating to utilize the e-waste urban mining, okay, for this off, okay, and this e-waste recycling using chemical and physical processes have been presented and explained by Professor Yulina and Professor Lee as well. And in this opportunity, I would like to focus on the metal recovery or chemical recycling e-waste. Okay, and this reference, we can see that the global e-waste generated increases every year. You can see here, and I believe that it will be even more near to the pandemic, because our life has been shifted to the online like this right now, and using the high technology and high mobility. Okay. And these are some examples of the e-waste. As you can see, for the lithium batteries in the electric vehicle, we can find cobalt, manganese, and lithium, which are the metals as well. And also nickel metal hydride batteries in the hybrid electric vehicle, we can find the rare earth elements or titanium, silver, medium here. Okay, and this is of television, or we call it tube monitor, and it's composed of the core and the third element and mentioned by Professor Lee. Okay, and according to the of energy, they have 16 elements as the critical mass, which have the high importance to the clean energy and high supply rates. Okay, and most of the critical metals are the rare earth elements. And it will be very good if we could utilize the e-waste as urban management research of critical metals and could promote the circular economy and sustainability. Okay, actually there are many methods for metal recovery from e-waste, but I would like to explain the most common one. Okay, and metallurgical, or we also know as smelting. Okay, and hydrometallurgical, or we also call it as the metallurgical using energy. And actually, these methods have some drawbacks. Like for pipe metallurgical, it requires the high energy consumption, produce the toxic gas and dust emission. For the hydrometallurgy, it is and consumption. And for metallurgical, it is difficult to integrate the material and that comes low efficiency. And these drawbacks may overcome the process intensification that could facilitate the faster kinetic consumption or waste production, resulting in sustainable production. And one example of the process intensification is rapid extraction. It required a high temperature above the boiling point and below the critical point. This area, it could facilitate the rapid mass transfer, high extraction yield, low reagent consumption, environmental and energy effective. And another example for the intensification, we utilize the electromagnetic wave. I would like to the microwave. Okay, it is non-contact energy transfer process, rapid and effective heating from inside material to outside material. Okay. And this is one subtopic that I would like to discuss with you: the recovery of yttrium and terbium from VCRT phosphor. And in this study, we heard three kind of process: yttrium and terbium from VCRT phosphor, closed vessel microwave, open vessel microwave, and conventional. And after the leaching process, offered yttrium and europium using the precipitation oxalic by got this recovery. Okay, and this is the result of the open microwave. As you can see, the pour and time can be controlled in here. The sample was put in here, and the microwave power and this condenser to avoid the evaporation. Okay. And from this result, you can see that increasing the microwave power increase leaching efficiency of yttrium and europium as well. It is because the ion collide and ion collision cause the conversion of kinetic energy to thermal energy. 400 watt was just for further are in that watt. Okay, and it's still from open vessel microwave. You can see that increasing sulfuric acid as a leaching agent could increase the leaching efficiency of metals. Okay, significantly, because increasing the sulfuric acid concentration increase the amount of the hydrogen ions that triggered the metal dissolution increase. Okay, and more and ion lead to accelerate the heating rate and reaction rate. And as you can see here, the limit amount lead leaching efficiency of lead was occurred because the formation of the insoluble lead sulfate. Okay, and polar was chosen for further experiment. The result of the closed vessel microwave, as you can see from this here that increasing the leaching rate could increase the leaching efficiency of yttrium and europium. And the highest leaching efficiency of rare elements were obtained at 125 degrees C. And the difference of yttrium and europium are endothermic. Okay, and this is the comparison of leaching efficiency and energy consumption using three of the leaching methods. You can see here that the leaching efficiency of yttrium were highest using pulsar microwave. And according to the energy consumption analysis, you can see that by using closed vessel microwave, required is the lowest one, about 400 kilojoule. And comparing the leaching efficiency of yttrium using closed vessel microwave, we obtain the highest leaching efficiency of the rare. Therefore, closed vessel microwave is effective and efficient for of yttrium and europium with active phosphor, the energy consumption and leaching efficiency of rare elements. Okay, and this is the characterization of the leaching residue. You can see the remaining compounds are zinc sulfide and sulfate, sulfate. And you could find any rare elements because most of the rare elements has been leached out. Okay, and the recovery product by precipitation and calcination at 750 C, you can see that the recovery product is oxide, and this is the recovery percentage of yttrium. And the second subtopic, I would like to discuss about the recovery of lanthanum, cerium, and neodymium as the rare elements from spent nickel metal hydride batteries. We use two-stage leach. First is to heavy metal. Second is to leach out the rare elements, and after the in the water, we could recover the rare elements using pH 0.5 and 1. Okay, selective recovery of rare elements provided. Okay, and for the first stage of conventional leaching, see that using acid selectively leach the metals here, not rare elements. Okay, because the insoluble RE phosphate perform the leaching process, and the high selectivity of leaching using phosphoric acid for the top over the E could occur here. Okay, and for the effect of phosphoric acid, you can see increasing the concentration of phosphoric acid could increase the leaching efficiency of the metals. Higher concentration yielded the higher leaching efficiency of metals. It's because the low pH solution was favorable, and 2.5 mole per liter was chosen for experiment because there are no significant. Okay. And for the solid to liquid ratio, high pH value of leaching hindered the dissolution of metal, spent nickel metal hydride batteries, increasing the to liquid ratio, increase the pH of the leaching solution, or 200 grams per liter was chosen for further experiment. The characterization of spent batteries and the the first leaching stage. Okay, you can see the nickel and cadmium were first stage of bleaching using waste phosphoric acid. And the mesh metals, lanthanum, nickel, sodium copper, and sodium nickel in spent nickel metal hydride batteries are very stable and difficult to be dissolved at room temperature. And this is the result of the second stage in critical water. Increased concentration of the sulfuric acid as a leaching agent could increase efficiency of the REE. Okay. Can you hear my voice clearly? Sorry.
Not yet, Bu Jenny.
Oh. Okay. Hello. Hello. Sorry. Hello. Yeah. Can you clearly?
Not yet,
Hello?
Jenny. It's not clearly.
Hello.
It's still unstable. It's still unstable, Jenny.
Okay.
So
Wait a
maybe we can share the PPT from here.
Okay. I made some how about here? It's clearly.
No, for me it's not.
Okay. Okay. Then. Okay. Wait. Let me deal with the next one. I'm sorry for the problem.
Bu Jenny, do you want me to share the presentation? Okay, Devi has done it.
Hello. Hello.
Hello, Bu Jenny.
Hello, Nisa. Hi.
Yeah.
Can you hear my voice clearly?
Yeah, it's better.
Okay. So let me share my PPT. So I made some change.
Devi already shared the screen, so you can continue the presentation.
Okay. I'm sorry for the problem. Okay. Let me continue. You can see from this result that increasing the sulfuric acid concentration could increase the leaching efficiency of metals, especially for the rare earth elements. Okay. And from the characterization of the leaching residue, you can see that the metal alloys and also the metal phosphates have been removed using 1 molar of sulfuric acid. Okay. And this is the recovery result. You can see increasing the pH could increase the percentage of the recovery of metals. But when we increase the pH above 2, the selectivity of the recovery of rare earth elements is no longer happen. Okay. And pH 1 was chosen for the most suitable pH condition for the REE, selectively precipitation of the REE. Okay, for the conclusion of my presentation, I would like to say that the leaching process of critical metals from e-waste is depending on the metal compound and the characteristic of the e-waste. And the acid type, acid and concentration, and acid and solid concentration, including pH, are important to determine the dissolution and leaching efficiency of metals from e-waste. The process intensification could enhance the leaching process in terms of the leaching efficiency of the metal and energy efficiency. And the simulation of freak is necessary to determine the pH value in recovery of critical metals by precipitation. And metal-ligand interaction is also important to design the recovery process by precipitation. And the critical metals recovery from e-waste is inevitable and imperative for the circular economy and sustainability. Okay, that's all my presentation. Thank you very much for listening. I give back to the moderator.
Yeah, thank you very much, Ibu Jenny, for sharing the knowledge with us. I will take a couple of minutes to deliver the key point from your presentation in Bahasa Indonesia. Bapak dan Ibu, saya akan menyampaikan beberapa poin penting ya yang telah disampaikan Ibu Jenny Lee dalam presentasinya. Memang dalam presentasi yang disampaikan Ibu Jenny lebih menggarisbawahi tentang potensi pemanfaatan limbah elektronik dengan mendaur ulang komponen-komponen yang bernilai. Salah satu prosesnya adalah proses leaching. Proses leaching logam dari limbah elektronik ini sebetulnya memang tergantung pada senyawa logam dan karakteristik dari limbah elektroniknya. Jenis asam, konsentrasi asam, dan padatan termasuk nilai pH menjadi penting untuk menentukan efisiensi pelarutan dan leaching logam dari limbah elektronik. Kemudian yang ketiga adalah intensifikasi proses dapat meningkatkan proses leaching dalam hal efisiensi leaching logam kritis dan hemat energi. Kemudian yang keempat, simulasi distribusi spesies dengan apa yang tadi metode sudah disampaikan, PHR-EEQC, diperlukan untuk menentukan nilai pH dalam pemulihan logam dari lindi dengan presipitasi. Yang terakhir adalah interaksi logam ligan juga sangat penting untuk merancang proses pemulihan dengan presipitasi. Itu adalah poin-poin yang sudah disampaikan Ibu Jenny dalam presentasinya. Kemudian saya akan cek terlebih dahulu apakah kita sudah mendapat pertanyaan dari peserta. So ladies and gentlemen, I would like to invite all of you to submit question that is directed to Ibu Jenny for this session. Any question from the participant? While we are waiting for the question, because we also still waiting for the second speaker to join us. I have one question actually, but I would like to invite a participant first who would like to speak directly to Ibu Jenny to ask question regarding the research that have been delivered by Ibu Jenny. Yeah. So we have Bapak Niam. Bapak Niam.
Yes, Miss Nisa, I would like to ask for presenter. Hello, can you hear me clearly?
We could hear you, so please.
Yeah. I want to ask you, the presenter, about the recovery. Sometimes for recovery, impurity as a challenge. So what the solution for reduce the impurity, especially if we want to recover the rare earth element.
Yeah. Ibu Jenny, are you still with us?
I don't know. Can you hear me clearly or not?
Yeah, we could hear you. Perfect.
Okay. Let me answer the question. Thank you for the question, Pak Niam.
Yes.
Okay. Yes. That's true that the metal recovery, especially for the REE, is very important. And to increase the purity of the recovery product, we need to consider about the leaching components. I mean the metal content in the leaching solution. Okay, and for the rare earth element, especially when we talk about elements, it's actually not very difficult to recover the rare earth elements because it has the special. I think it has the special chemical properties which contain three valency of the metal charge, trivalent. Okay, so it is, and based on my study, I found that rare earth elements can be very selectively by using at each value. Okay, so yeah, but it is also depending on the what chemical, or maybe you can also use the oxalic acid is also for the scope. Yeah, we figure out can be used for the metal rare earth elements recovery. Hello.
Yes, Miss Jenny. Thank you for your.
Hello.
Hello.
Yeah, Jenny, we could hear you, but your video. Okay.
Sorry. Did I answer your question? Not yet.
Bapak Niam, apakah sudah terjawab tadi pertanyaannya?
Yes, very clear. Thank you, Miss Nisa.
Okay. Thank you.
Yeah. Okay. We move on to the next question regarding the leaching process, because Ibu Jenny also studied in Taiwan. Maybe you could also explain the process in Indonesia and also in Taiwan, whether this leaching process is still using or is still used as the main process for the electronic waste treatment, or not in both in Taiwan and Indonesia in general. So please, Ibu Jenny.
Yeah, thank you for the question. I'm not really sure about the industrial application of the metal recovery in Taiwan, and also for Indonesia, I'm not really sure as well. I think it's the metal recovery using hydrometallurgical, especially of our leaching, has not been applied yet industrially or in the large scale for Indonesia and maybe in Taiwan. Maybe you can ask Professor Lee, who is expert in e-waste recovery in Taiwan. Yeah, that's much I know. Nisa, yes. Did I answer your question? Or maybe, yeah, we can ask Professor Lee or Professor Liu for the Taiwan leaching recovery of metal by using leaching in Taiwan.
Yeah. It would be nice if we also still have Professor Lee here, but I think he already left.
Okay.
Professor Lee left, so yeah, but that's fine.
Actually, most of the recovery process, metal recovery process in, I think in Indonesia, did not start yet. Yeah, especially for the leaching processes for metal recovery. Yes.
Hello.
Yeah, Professor Lee, are you still with us?
Yeah, but okay. So you're asking about leaching process for metal recovery, right? And
yes, Professor.
because in Taiwan, for most of the precious metal recovery is done by hydrometallurgy method, which means we have to do the metal leaching, and the technology for metal leaching is no limit. I don't know, just they can use any kind of acid to do the leaching, as long as the final wastewater can meet the EPA requirement, and during the leaching, no human health will be damaged. Then you can do it. And most metal recovery in Taiwan is done by leaching first. Yes. That I don't know. Is that answer the questions or not?
Yes, thank you very much, Professor Lee.
Okay. Thank you.
Thank you very much, Professor Lee.
Yes.
Yeah. So that was the answer from Ibu Jenny and also Professor Lee regarding the leaching process in Indonesia. So do we have another question from participant, or is there anyone who would like to speak directly to the presenter? Yeah. So this we have one more question. Yeah, how about scale up to industrial scale? To scale up the process from the lab scale to the industrial scale, and how about the applicability regarding the purity? Ibu Jenny?
My partner during the PhD study in Taiwan, and I believe that he's still in there. Yeah, thanks very much for the question. I think it is also a good challenge for us to industrially to scale up the research in the laboratory to the industrial scale. Yeah, but I think that it should be studied again for the large scale, because the large scale and the large scale should have a different factor or difficulties. Yes, but I think it's possible to do the scale up for the metal recovery, critical metal recovery from the e-waste. Yes. Did I answer your question?
Thank you for the answer. So the question was from Yuhei Tanaka. Did Ibu Jelly answer all your question? I hope she does. Yeah, we have. Okay, Professor Felicia raised hand. So please, Professor.
Yeah, thank you, Nisa. Actually, my question is for Professor Lee, because I was curious about the step how Taiwan become successful. I mean, in the e-waste management. I think the process mostly is about regulation, right? How to make the regulation and also impose in the society. So I think we can learn if Professor Lee would like to share how the process in Taiwan established this e-waste management. Thank you.
So, Professor Lee?
Okay. Yes.
Yeah.
I think this management system started from 34 years ago. So that's mean long time ago. And the original, I think, we follow the German system. I think in German there's a green duct system. That green duct system is for, if I remember, is for container, for PET bottle, I think. I kind of forgot. So anyway, we are not the first country in the world to adopt this, how do we call, producer responsibility recycling system. So originally, I think we follow from German system. But in German system, they only focus on one type of container. But in Taiwan, we focus, right now we have 33 items, many items was conducted. And also, original, about 30 years ago, the system is not like this. The system is, we call producer responsibility, right? So right now, the producer responsibility is only to pay the money, the recycling fee to the government. But in the beginning, the design is not like this. In the beginning, is the producer, it take the whole responsibility to do the recycling. That means in the original, the producer has to form the organization. They have to construct a management system, and they have to do the actual recycling work, and then report the result to the EPA. However, during this period, there are many complaints. You can say complaint, or you can say many, how to say, I should know how to say. I don't know how to say, but there some kind of problem. It's the question or the accuracy of the report, whether it's the organizing file report. For example, they should file a recovery rate to the EPA, say, okay, in this year, the appliance, for example, refrigerator recycling rate recovery is reached 80%, for example. But because this is done by the producer itself, so it's questionable whether they reach this 80% target. And also there's money involved in this system. For this kind of system, the most important is the financial mechanism. So somebody had to pay the money, and somebody will get the money. And if there's money involved, usually there's some kind of trouble. So somebody will say there's some kind of unfair, or anyway. So maybe after 10 years, I forgot, maybe after 10 years implement by producer itself, then government decide, say the government, that means EPA had decided the EPA will construct the management system and do the actual recycling work. However, the producer only had to pay the money. That's it. They finish their responsibility. So it's right now, I think after 33 years implementation of this system, I think Taiwan has accumulated a lot of experience. So, but it takes time to explain what's the reason behind this mechanism. Also, sometimes it's difficult to explain in public why we choose this kind of system. For example, I mentioned the auditing is important in this system. Sometimes the auditing cost is a lot compared to the actual subsidy. Maybe for some item, it may more than the subsidy. But however, we have to make sure this is fair WE management system because it is government control this system. So the government is how do you say, the official employee. so they don't want to get some kind of trouble involved in the money transaction. So anyway, if you would like to know more, maybe we have to talk privately, so we have more time to discuss it. Thank you.
Okay, bro. Thank you so much. Maybe sometime later, if you have time, you can visit us and then we can discuss further.
Yeah.
Thank you so much, Professor.
Yeah, also welcome you to welcome Taiwan, visit Taiwan.
Thank you, Professor.
Yeah, thank you.
Thank you very much, Professor Lee and Professor Felicia for the question. Bapak dan Ibu, seperti yang sudah disampaikan Profesor Lee tadi, bahwa implementasi di Taiwan memang sudah tidak dalam waktu yang singkat, lebih dari 30 tahun seperti itu untuk implementasinya. Dan untuk panduannya sendiri, Taiwan memang banyak mengacu pada Jerman untuk implementasi recycling dari limbah elektronik ini. So, ladies and gentlemen, I think we have covered all the questions. First of all, I would like to apologize because unfortunately, the next speaker is not able to join us this morning. So we need to end today's webinar after this. We will send all the materials through the email after this webinar finish. And we also will send the certificate for the participant who have already filled the attendance list that have been provided by the committee. We will send all the certificate and material via email. Again, on behalf of the committee, I would like to apologize because we are not able to continue this webinar with the second speaker. So thank you again for all presenters and participants who have already submitted questions in this second session. Thank you. Then I will give this time back to the MC. Thank you.
Thank you very much, Ibu Nisa, and all of the distinguished professor and speakers today, and all of the participants. We are very sorry that the director of hazardous and non-hazardous from Ministry of Environment and Forestry cannot attend it because just called by the Director General to have some activity in Jakarta. But we will be sent the PPT of the Director of Hazardous and Non-Hazardous Waste by email, as I mentioned by Ibu Moderator, Ibu Nisa. And thank you very much. And we will also wait for another attended for other webinar, because we will have several theme of the webinar in these years. Thank you very much for coming, and we are officially close this webinar today. Thank you, and we give applause to all of the distinguished professor and speaker. Thank you very much, Professor Lee, Professor Yulina, and Ibu Dr. Jenny, and Ibu Nisa, Ibu Feli. Thank you.
Thank you, Bu Wawa. Thank you, Professor.
Terima kasih semua Bapak dan Ibu.
Oke, bye-bye. Thank you.
Bye-bye. Thank you. Terima kasih Bapak dan Ibu. Mohon maaf karena Pak Direktur tidak dapat menghadiri acara ini. Beliau membatalkan di menit-menit terakhir karena beliau sedang dipanggil oleh Ibu Direktur Jenderal berkaitan dengan meeting yang ada di Jakarta. Tetapi kami akan tetap membagikan PPT beliau kepada Bapak dan Ibu partisipan semuanya dalam bahasa Indonesia, dan juga akan kami kirimkan melalui email bersama dengan sertifikat. Demikian yang dapat kami sampaikan. Terima kasih atas kehadirannya dan ditunggu kehadirannya pada webinar-webinar yang lain, karena kami akan memiliki seseries webinar yang dilaksanakan di tahun 2022 ini. Terima kasih, sehat selalu, dan kita ucapkan selamat juga untuk Hari Bumi di tahun 2022 ini, dan kita semua bisa berkontribusi untuk men-save our planet. Thank you very much. Terima kasih. Kami end meeting untuk hari ini. Terima kasih semuanya.
Thank you. Bye-bye.
Thank you. Bye-bye.
Terima kasih semuanya.
Terima kasih. Sekarang. Terima kasih. Kami mohon izin untuk bisa men-stop